Of course, it's just as important to us to be able to interpret confidence intervals as it is to create them. We want to be able to look at computer output for confidence intervals and answer all sorts of questions about them, show that we understand what they're showing us and how to interpret them. So let's look here. We have a study where students in sample 1 were shown positive evaluations of an instructor, and the students in sample 2 were shown negative evaluations of the instructor. Then all subjects were shown the same 20-minute lecture video given by the same instructor. They were then asked to rate the instructor using 3 questions, and a summary rating score was calculated. Were students' ratings influenced by the prior student evaluations? All right, so we have the confidence interval outputs here. Again, StatCrunch and Minitab. I would never give you both of them in an exam or a project. I would only give you one of them and ask you a whole barrage of questions about them. So let's look at both of them. And you can see that Minitab is the one that makes it a little bit more obvious that, one, you're working with a 2-sample t-test, and CI stands for confidence interval. So that lets you know, hey, this is an independent t-test. That's what we're doing here, as opposed to a paired t-test, which we did in 11.2. And then StatCrunch, it's a little bit less obvious, but you can kind of tell it from mu1 minus mu2. You're not talking about paired. It doesn't say anything about paired anywhere in here. So that means it's the independent one. All right, so then all that I highlighted right here in this little yellow box is the sample data from the 2 different samples. Now bear with me if you are working with this in the fall of 2014. I've actually added a couple questions and modified a couple things in here, so follow along and scratch off what you need to because it'll be slightly different for fall. I'll fix it for winter and beyond. All right, so how many students were shown a positive review? That would be N1 equals 25 right here. And then what was the average rating? That would be 2.613. That's the X bar for that group, for group 1. And the standard deviations right there, standard deviations given, 0.533. And then I blocked off the standard error because a great question for me to ask is, how do you calculate standard error? What does that SE mean? So standard error we learned in section 8.1. It's been a while. 8.1, we learned that the standard error of x1 or anything, any x bar, is approximately s over the square root of n. So in this case, it's S1, standard deviation for group 1, divided by N1, the sample size for group 1, which would be 0.533 divided by the square root of 25, which is about 0.11. And just in case you don't believe me, if I take 0.533 and divide it by the square root of 25, I get about 0.11, 0.1066. All right, so that's where that came from. And I also just throw it up here real quick. What SE stands for, remember, is standard error. Standard error of the mean for group 1. It's the spread, but for group means rather than for individuals. Standard deviation is for individuals. So this is for single student scores, and this is for the group of students, average. All right, now how many students were shown a negative review? What was the average for that group? And what's the standard error for that group? Okay, so that would be the other section, which is group 2, which is 24 for the sample size, 2.236 for the mean. I blocked off the standard deviation here, so we'll figure that out in a second, but the standard error for the mean is 0.11 again. Okay, so same standard error. So I put 24, 2.236 and standard error, but now I've got them all labeled with little subscript 2s because this is for group 2. All right, now I want to add in this. I want to compute the standard deviation for the negative group. S, of course, is standard deviation. Little subscript negative means you want it for that negative group, which was 2, group 2. All right, so let's look at this for a second. We know that the standard error is going to be the standard deviation for group 2 divided by the square root of the sample size for group 2. But we already know the standard error is 0.11 because it says so right in there. Right up here in the orange box. See that? 0.11 for group 2. Okay, so we know the standard error is 0.11. We know the square root of n is the square root of 24. So to solve for s, you just multiply both sides by the square root of 24. This will cancel over here. Square root of 24 over square root of 24 is 1. And then when you multiply it over here, you'll get like that. And that means that S is, because these will cancel here, they'll be gone. That means that S is approximately whatever 0.11 times the square root of 24 is. I guess I can leave that in there. All right, so 0.11, so let me grab a calculator, 0.11 times the square root of 24. So 0.5389. It's a little bit different than the other sample. They're close, but they're not exactly the same. That's just a little review question from chapter 8 to throw in there. It's nice to be reminded of that stuff because it might show up on projects or exams or that kind of thing. So it's good to have it in there. All right, now what does StatCrunch and Minitab state are the degrees of freedom? If you'll remember, the two programs do not always agree about degrees of freedom, and that's because they're using slightly different methodologies, slightly different philosophies for finding it. They're both based in that big formula we saw before. Oh, it's been a while. Let me go find it. There it is, that thing. It's based off of this huge formula here, which we're not really doing. So they both kind of use that, but then they do different things with it. So if we look at our outputs here, StatCrunch says it's 46.829, and then Minitab says 46. Minitab rounds it down, essentially. Okay, so I'll put those in there. There, we have those two values right there. And to match the highlighting that I have in the outputs up here with the green boxes, I'll give it a green box right there. All right, next question is asking what the confidence interval is, so you might as well look at them right now. This one says 0.0676. It's got more decimal places on the StatCrunch output right there. And this is 0.6864. And then when you look at the Minitab output, they've rounded to 3 decimal places, so 0.067 and 0.687. It doesn't really matter which one you just use whichever one's convenient for you. All right. So that's the answer to this part. That's all there is to it. It just wants the confidence interval, so you just say what it is. It's that value. There. All right, now we want to compute the point estimate for the difference between the two groups using the confidence interval. Okay, that's key. We're going to use the confidence interval to do this. All right, so remember that the point estimate is in the center of your confidence interval. So let me remind you of that. Now, since it's the center of the confidence interval, what I want to do is I want to take the low end and the high end, add them up, and divide by 2. And I'll know what my middle is. So I'm going to take 0.067 plus 0.687, add them up, and divide by 2, and I'll have my middle, which is 0.377. So this is 0.754, and that makes 0.377. All right, now what about the margin of error? Well, remember the margin of error is the distance from the edge to the center. Let me draw you a picture. Okay, here's the picture. So here's your interval kind of shaded in dark. You can see you got your right-hand edge over here, your upper bound over here, which is 0.687. You got your lower bound over here, which is that big black dot there, which is 0.067. And you've got your middle, the center, which you just found, which is 0.377. That's your point estimate. That's the center of your interval. Now the error is the distance from one edge to the other. If you will, it's from the upper to the middle or the middle to the lower. In other words, it's half the width of the interval. So if I take my interval width, now to find how wide your interval is, you subtract your higher minus your lower value. So you take your upper minus your lower, which is 0.687, subtract 0.067, and I get 0.62. Then I'm going to cut that in half, and I get 0.31. So I'll take 0.62, which would be 0.31. And there we have it. That is our margin of error. All right, now does this interval suggest that there is a significant difference between professor ratings for students who were shown a positive review and a negative review? Well, remember, all through chapter 11, if there's no difference, that means you're sticking with your null hypothesis. I mean, your null hypothesis is that group 1 and group 2 are the same, which means if you subtract group 1 minus group 2, the mean for 1 minus the mean for 2, you should get about 0. I mean, maybe not exactly 0, but they should be close to 0. Our confidence interval, however, does not contain 0. Our lower hand edge is still above the 0 mark. That implies that there is a significant difference between professor ratings for students who are shown a positive and negative review, because 0 is not in the interval. All right, we're done with section 11.3. Sorry about throwing a couple new questions at you there, but I really think it's helpful for your exams and your projects. I'll see you back here for section 11.1.